Hi, this is Javin Kharor, a chemical engineer by profession, going to continue today's topic, Introduction to Hydrocracking. Now, what is that? Hydrocracking is the pivotal process in the petroleum refining industries, aimed at breaking down complex hydrocarbons into simpler, more vulnerable molecules. This method essential converting heavy oil into light products such as diesel, jet fuel, gasoline, all which are high demand globally. Understand the hydrocracking process is crucible for interested in the interfaces of the petroleum refinery. Its core hydrocracking involves chemical reaction, heavy hydrocarbon molecule, hydrogen under high pressure and temperature, facilitated by catalysts. The process began the crude oil fraction being mixed with hydrogen. The mixture passed over fixed bed catalyst, high temperature ranging 260 to 425 degrees centigrade and pressure between 3000 to 5000 psi. The catalyst typically consists metal such as platinum, palladium, mix of tungsten, nickel supported, alumina and silica alumina base. Now role of catalyst. Catalysts play a significant role in hydrocracking process. They accelerate the chemical reaction without consume in the process. Different catalysts influence hydrocracking reaction various ways affecting yield and quality final product. Choice of catalyst depend design and product specific feedstock characteristics. Now advancement in catalyst technology continue improve efficiency and selectivity hydrocracking process. One of the primary advantage of hydrocracking ability to produce higher yield, valuable light product compared to other refining process such catalytic cracking. Hydrocracking break down heavy hydrocarbon but also saturate hydrogen, reducing olefin contact and result more stable and cleaner burning fuel. Additional process remove impurity, sulfur, nitrogen, product meet strict environment regulations. Hydrocracking is versatile and can tailor produce the different output depend market demand. The process widely used, producing high quality diesel. They are cleaner alternatives. Traditional diesel fuel also employed the production of jet fuel, lubricant and base oil by alert the operating condition, type of catalyst, refinery, adjust the product slab and align fluctuating market requirement. Now, environment impact. The environment benefit hydrocracking are notable by converting heavy oil into cleaner burning fuel. Hydrocracking contribute reducing overall emission petroleum product, removal sulfur and nitrogen compound during process help meet environment standard and limit air pollution. The world increasing shift sustainable energy source. Process hydrocracking enhance efficiency and clean line as conventional fuel remain relevant. Now, despite advantage, hydrocracking is without challenges. The process requires significant capital investment, operational cost due to high pressure and temperature, catalyst deactivation over time due to coke formation and metal deposition. Another concern that require regular management. However, advancement technology continue push the boundary, making process more efficient and cost effective. Now, looking forward, hydrocracking is expected to play a crucial role meeting the growing demand of the cleaner fuel as research development effort continue process revolve become and more efficient with enhanced catalyst and better waste management strategy. Hydrocracking essential combination of two processes hydrogenation and cracking. Therefore, hydrocracking utilizes bifunctional catalysts. The catalyst, high active noble metal, used hydrogenation, platinum and palladium used in hydrocracking are very susceptible. Poisoning, great care must taken, remove sulfur and feedstock. The process typically accompanied by hydrotreating, remove the sulfur, nitrogen and oxygen. Additional by catalytic cracking is carbon rejection process. Hydrocracking is hydrogen addition process. Therefore, some of the complications, coking, are avoided during hydrocracking process. Several factors distinguish two cracking processes. However, typically both processes are used in order to provide optimum yield, product economical, efficient manner. Advantage of hydrocracking include ability, handle a wide range of feedstock as well selectivity of distillate. The primary objective of both cracking process produce lighter saturate hydrocarbon with reduced molecular weight and boiling point heavy oil, but due to fact aromatic ring cannot crack until they are fully saturated with hydrogen. Hydrocracking process allow the processing of more aromatic feedstock include byproduct catalytic cracking, light cycle oil, further modifying reactor configuration, fixed bed, emulgated bed and expanded bed, catalyst and hydrogen carbon ratio. Hydrocracking can highly flexible with ability process both relatively light feedstock as well as heavy vacuum residue in the light and middle distillate. Another difference between hydrocracking and catalytic cracking are change in enthalpy. Catalytic cracking is endothermic process. Hydrocracking is exothermic process. Heat for catalytic cracking is supplied. Regeneration of catalyst. Evaluation of catalytic cracking. Thermophore and modern fuel catalytic cracking continue improve upon the thermal efficiency of the process. Now hydrocracking process have several advantages. Crude catalytic cracking. Hydrocracking comparison more costly process. Therefore, it is exclusively used. Refinery. They operate process in order to produce more desirable yield of product. Now, catalytic cracking FCC versus hydrocracking. The point is carbon rejection, hydrogen addition. Now, catalytic cracking is endothermic reaction, while hydrocracking is the exothermic reaction. Now, catalytic cracking is an acid catalyst. Hydrocracking is a metal catalyst. Catalytic cracking generates more gas. Hydrocracking less gas required. Catalytic cracking more coke formations, where hydrocracking less coke formation, and it's a costly process. Now, hydrocracking involves carbon-carbon bond, more liquid yield with hydrocracker, more hydrogenated product. Cracking is less sour. Secondary cracking reaction are minimized stabilization of active species hydrogen. Hydrocracking more flexible feedstock, refinery feedstock can be possessed. Carbon-carbon bond breaking after saturation with hydrogen. Now compare catalytic cracking, carbon rejection process and hydrocracking respect major attribute. Both project clearly flexible refinery, wide range of crude oil feedstock. Both the process are need optimum conversion oil into desirable refinery product. Now hydrocracking. Hydrocracking and catalytic cracking are the presence at hydrogen gas. Unlike hydrotreater, hydrocracking use hydrogen carbon-carbon bond where hydrotreatment is conducted. Hydrocracking and product catalytic hydrocracking process 265 million tons of petroleum was proceed with the technology. Main feedstock vacuum gas oil and heavy fraction of petrol. The product of process are saturated hydrocarbon, depend reaction, temperature, pressure, catalyst activity. The product range, ethane and LPG. Heavier hydrocarbon consists mostly isoparaffin. Hydrocracking normally facilitated bifunctional catalyst. This is capable of rearranging breaking hydrocarbon chain as well adding hydrogen, aromatic olefin to produce naphthane and alkane. The major product of hydrocracking, jet fuel and diesel, but lower sulfur, naphtha fraction and LPG produce. All the products have very low content sulfur, other contaminant, coal reducing gas oil and naphtha range 10 ppm sulfur low. Hydrocracking process depend nature of feedstock, relative rate of competing reaction, hydrogenation and cracking. Heavy aromatic feedstock convert lighter product under wide range, high pressure 6900 kilopascal and fairly high temperature 399 816 degrees centigrade in the presence of hydrogen and special catalyst. Now, feedstock quality starting temperature 435 degrees centigrade, and hydrocracking is licensed technology due to complexity. Typical licensor also catalyst provider. Also, the unit internal often parented the process license and their design support specific function of the catalyst. Hydrocracking is a catalyst chemical process, petroleum refinery for converting high boiling constitute hydrocarbon petroleum crude oil to more valuable lower boiling product gasoline, kerosene, jet fuel and diesel oil. The process takes place hydrogen rich atmosphere, elevated temperature and pressure. Basically, the process crack high boiling, high molecular weight hydrocarbon in the low boiling, lower molecular weight olefin aromatic hydrocarbon and then hydrogenated them. The sulfur and nitrogen hydrocracking feedstock are extract hydrogenated gaseous hydrogen sulfide and ammonia, which subsequently remove. Result hydrocracking product essential sulfur and nitrogen impurity consists mostly paraffin hydrocarbon. Hydrocracking plants are capable processing wide variety feedstock, different characteristics produce broad range product such as design and operate, maximize production gasoline, blending component to maximize production diesel oil. There are good many different priority and pro-priority hydrocracker design available under license in case many other process used in petroleum refinery. Also, number of different hydrocracker process equipment. Single stage, once through hydrocracker, the configuration uses only one reactor, uncracked residue hydrocarbon oil and bottom of reaction product, distillation tower, not recycled. Further cracking for single stage hydrocracking, either the feedstock must first be hydrotreated and remove ammonia, hydrogen sulfide and catalyst used in the single reactor, capable hydrotreating and hydrocracking. Now, there the single stage hydrocracker with recycle, two stage hydrocracker, and its susceptible poisoning sulfur nitrogen compound, the hydrocarbon liquid phase, high pressure separator, the pressure let down bar in the low pressure separator, the reduction pressure partially vaporized, flash evaporation and resulting vapor routed to hydrocracker and end product hydrocarbon liquid phase, low pressure separator, heated, fuel fired heater fed into the fractionator. The fractionator continues distillation tower, separate the hydrocracker and stream naphtha and diesel oil of gas and tau associate reflux term of gas, lower pressure separator. Not all feedstock hydrocarbon reactor are hydrocracked, converted lower boiling, lower molecular weight hydrocarbon, bottom stream. The fractionator consists of unconverted hydrocarbon. First stage reactor stream is reactor and first heated by hot effluent reaction product. From the second stage reactor, recycled feed is heated further, fuel fire heated before it enter top of second stage reactor, flow downward through three bed of catalyst, temperature and pressure condition. The second stage reactor depends same variable. Determine condition. First stage reactor, a broad generally. Pressure in the second stage reactor generally 80 to 200 bar and temperature ranges 345 to 425 degrees centigrade. Hydrocracking, cornerstone modern petroleum refining, enabling the production of high value cleaner fuel and heavy crude oil fraction. Its ability adopt changing market demand while addressing environmental concerns make invaluable process, energy sector, all technology advance. Hydrocracking continue, refine, ensuring place future landscape of energy production. Okay, this is up to our today's topic, introduction of hydrocracking. I hope you get sufficient knowledge after watching this video. Goodbye and do take good care of yourself.